Hey there, future scientist. Welcome back to Maths Masti. I am Jatin Joshi, and today we have something exciting lined up for you. We are going to break down chemical reactions and equations, one of the fascinating topic in chemistry for class 10th. Whether you are budding chemist or just looking to ace your exam, trust me, by the end of this video, you will have a crystal clear understanding for this topic. Let's start by asking a simple question. Have you ever seen a chemical reaction in action? From a matchstick burning to rust forming on metal, chemical reactions are happening all around us. And you know what? We can even write them down in a special language called chemical equations. Pretty cool, right? First thing first, what is a chemical reaction? Simply put, a chemical reaction is a process where substance called reactants are converted into new substance called product with different properties. The key point here is that bonds between atoms are broken and new bonds are formed. Simply what? Bonds between atoms are broken and new bonds are formed. Here is an example. When hydrogen gas reacts with oxygen gas, we get water. The equation of this is written like this: 2H2 plus we get 2 molecules of water. This is simple reaction, but we will dive deeper into the type of reaction shortly. Types of chemical reaction. Now, just like we have different genres of movies, action movies, comedy movies, drama, chemical reaction also have different types. Like, let's break them down. First, combination reaction. Combination reaction. The first type is combination reaction. This is like a team up between two or more reactants to form a single product. It's like when two superheroes come together to defeat a villain. Let's look at an example. Our example is like that: magnesium. When magnesium combined with oxygen, it produces magnesium oxide. Is it balanced? This reaction is not balanced because two here is one magnesium and two oxygen, but there is only one oxygen molecule. So to balance it, we will simply put two in the front of them. In this reaction, magnesium combines with oxygen to form magnesium oxide. See how two reactants combine to form just one product. That's a combination reaction. Our second reaction is decomposition reaction. Decomposition reaction. Think of this as the opposite of a combination. In this reaction, a single substance breaks down into two or more simpler substance. Like here is it an example of calcium carbonate CaCO3 break down to form calcium oxide and carbon dioxide. When calcium carbonate is heated, it breaks down into calcium oxide and carbon dioxide. This is an example of decomposition reaction. Our third reaction is displacement reaction. Displacement reaction. In this, one element displaces another from a compound. Think of it as a wrestling match where one wrestler throws another out of the ring. The example here is it zinc plus CuSO4. When zinc reacts with copper sulfate, zinc displaces the copper with the from copper sulfate and form ZnSO4, zinc sulfate, and copper get separated. In this case, zinc is displaced by copper. Zinc is displaced copper from copper sulfate to form zinc sulfate and copper metal. See the displacement reaction. Our fourth reaction is double displacement reaction. Our fourth reaction is double displacement reaction. This is like a dance where two compounds swap their partners. Here two compounds exchange ions to form new products. Our example is when sodium chloride reacts with silver nitrate, it forms silver chloride plus sodium nitrate. Sodium chloride and silver nitrate reacts to form silver chloride and sodium nitrate. Both compounds switch partners, which is what make this a double displacement reaction. In a single displacement or a displacement reaction, only one compound got displaced. But in double displacement reaction, two compounds get switched. Our fifth reaction is redox reaction. Finally, let's talk about redox reaction, which stands for reduction oxidation reaction. It involves the transfer of electrons between reactants. One element loses electrons, which is called oxidation, and the other gains electrons, called reduction. An example in Swan, iron reacts with oxygen to form rust. When iron ferrous reacts with oxygen, we found ferrous oxide. This is not balanced. Now it is balanced. In this reaction, ions get oxidized, means loses electrons, and oxygen get reduced, gain electrons. These reactions are super important because they explain everything from the rusting of metal to batteries and even digestion. Now let's take a step forward and talk about writing chemical equation. We know chemical reactions occurs, but how do we express them in a form we can understand? There were chemical equations come in. The first type of the equation is skeleton equation. A skeleton equation is just the unbalanced version of the chemical equation. It shows the reactants and products, but the number of atoms on both sides is not equal yet. For example, we talk about H2 react with O2 and get the product H2O. This is a skeleton equation. As we talk about skeleton equation, this is simply an unbalanced version of chemical equation. We can see here that there are two hydrogen atoms on the reactant side and the product side also two hydrogen atoms. But for the oxygen, there are two oxygen atoms in the reactant side, but in the product side, this is only one. This simply shows only the reactions, not the atoms on both the sides. The second one is our balanced chemical equation. Balancing chemical equation. But there the catch. Our skeleton equation need to be balanced in the balanced equation. The number of atoms of each element must be the same on both the sides. Let's balance the equation for the reaction between hydrogen and oxygen to form water. Our unbalanced equation is H2O2 produce H2O, simply water. To balance, it follows these steps. First, count the number of atoms of each element on both the sides. Hydrogen are two hydrogen atoms. Hydrogen atoms are two in the reactant side and hydrogen atoms are two on the product side. Oxygen atoms are two in the reactant side, but oxygen atom is only one on the product side. Second, adjust the coefficient, the number in the front of the formula, so that the number of atoms on both the sides get equal. For now, we have to adjust or put the number in the front of the equation to make the balance. So what should we do? We should count here. Hydrogen atoms are 2 in the reactant side and same as in the product side. Oxygen atoms are 2 in the reactant side, but there is only one oxygen atom. So we simply put 2 here. But now the equation or the atoms will change. There are 4 hydrogen atoms now, but in the reactant side there is only. So we should put 2 in the front of H2. Now the equation is completely balanced. There are 4 hydrogen atoms in the reactant side and the 4 hydrogen atoms in the product side. There are 2 oxygen atoms in the reactant side and the 2 oxygen atoms in the product side. Now we get this reaction after balancing it 2H2 plus O2, we get 2 molecules of H2O. Third one, law of conservation of mass. Great. Now let's talk about a super important principle, the law of conservation of mass. This law says that matters cannot be created or destroyed in a chemical reaction. So the total mass of the reactants must be equal to the total mass of the product. Let's quick verify this with an example. If we burn a piece of wood, the mass of the wood along with the oxygen in the air will equal the mass of the ash. Water vapor and gas is produced. Nothing vanishes. Means if we burn a piece of wood, so the mass of the wood along with the oxygen in the air by which it will combust will equal to the mass of S after burning the wood and the water vapor present in the wood and the gases produced by the burning wood. They all are equals after burning, before burning. The real life application of chemical reaction. What is it? Chemical reactions are not just theoretical, they happen all around us in real life. Let's explore a few examples. Do you know the photosynthesis is a chemical reaction? It's a combination reaction where plant uses sunlight to combine carbon dioxide and water to make glucose and oxygen. Here is the equation. The plant combines the carbon dioxide, water, and the sunlight to produce glucose C6H12O6 plus oxygen. This is not a balanced equation. This is unbalanced, or we can say it is skeleton equation. Now we should balance it. 6 molecules of carbon dioxide plus 6 molecules of H2O. It combines and form 1 mole of glucose and 6 molecules of oxygen. Also, have you ever wondered how your battery works? When you use your phone, the battery undergoes a redox reaction where zinc is oxidized and copper is reduced. This process generates energy. Now let's test your understanding with a few practical problems. Don't worry, I will guide you through it step by step. It's simply a combustion of methane where CH4 reacts with oxygen to form carbon dioxide and hydrogen H2O, water molecules. Now, first of all, we give the coefficient to all of them. Means ACH4 plus BCO2 CCO2 plus DH2O. Now we will count, or we will make an equation for carbon. For carbon atom, we will count the carbon atoms in the reactant side. There are one carbon atom, so A. In the product side, there are how much carbon atoms? There are one carbon atoms, means C. Simply we can say that A is equals to C, because according to the law of conservation of mass, for hydrogen atom, for hydrogen there is simply 4 hydrogen atoms in the reactant side, so we can write it here A4 4A, and on the product side there are 2 hydrogen atoms. There are 2 hydrogen atoms, means 2D, or we can say that D is equals to 2A. Now for oxygen, 2B on the reactant side, which is equals to the product side, so here oxygen are 2C plus 1D. Here is there are 3 equations we get, 1 2 and 3. let A is equals to 1. If A is equals to 1, then C is also equals to 1 from the equation number 1, because A and C are equal to each other. So if we let a is equals to 1, automatically c is also equals to 1. Okay. On putting the value of a in second equation, we will get d is equals to 2. Now we get a, c, d. The remaining is b. From the equation number 3, we should put all the coefficient value in this equation. So now 2b is equals to 2c plus d means 2 and c is equals to 1 plus d is equals to 2. On further solving, 2b is equals to 2 plus 2. b is equals to 4 and b is equals to 4 by 2 which is equals to 2. So automatically b is equals to 2. We get all the equation, all the coefficient. So now on putting the values of in the the skeleton equation is ACH4 plus BO2 reacts and form CCO2 plus DH2O. On putting the value of all the coefficient in the equation, we'll get CH4 plus 2O2 combines and form CO2 plus 2H2O. This is now balanced. Well done everyone. You have learned the basics of chemical reaction and equation. I hope you enjoyed this deep dive into the subject and feel more confident in your understanding. Remember, chemistry is all around us and now you know how to write and balance chemical equation. Keep practicing and I'm here to solve your queries. You will master this in no time. Don't forget to like, share, and subscribe to Maths Masti for more awesome videos. Drop any questions or suggestions in the comments below. I had loved to help you out. Until next time, keep experimenting and stay curious. Thank you for watching. Subscribe my channel for more educational content.